Hello everyone, welcome to Normal Maths. This is a game that came out last year. I think it's kind of like, if folks know Gestalt OS and the various other games in that kind of space where it's like weird symbols and they mean something, you got to figure out what they mean. I think it might be a single screen puzzle. I think there might be no audio as well. I'm not here. Oh, no, I thought I heard audio, but there wasn't any. Yeah, so I guess we can place things down. We can't place it on the number. The 6 has gone down. Does that mean? I mean, it probably means something. Oh, now 6 has gone up with that. Okay. Okay, but then that's gone down. So is that just saying that this is a valid thing to put between these two numbers? I guess I want something that means add and something that means equals. Is it that and that? Okay. Okay. So maybe let's start writing some stuff down. Does this mean, like it's possible it's tricking me, but I'm going to draw it out. I think these are, some of these look a bit like, is it like symbols used to represent elements or whatever? And then, so we're saying that might be plus. And then the other thing is going to be equals. Slightly confusing that I've written that equals, but whatever, I'll understand it. I have a 1 here. Oh, so that symbol is fixed in place. So that's 1 plus something. What are we trying to do? 2 out of 18. So we can move these again. Okay, so I guess that doesn't have to be plus and equals. We could change it. A 36 there. Oh, what's that even going to mean? There's no like number here. What is that going to mean? I guess we need to experiment some more. So let's say we have, okay, so 2 out of 18 is now 0 out of 18. I think there's 18 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, and I just have to make them all raise up. So I guess that probably just means they all need to be part of a valid equation. So interesting, those two numbers are already, like, they've got a thing between them which we think is equals. Well, there's only those 5 symbols. We should just experiment, I guess. Can things go like diagonally, or what do we think this does? That makes that go down. But this also made that go up. Maybe that, I was going to say, maybe that also means equals. 6 does equal 6. But actually, that's a good point. So if I put that there, it doesn't like it. Is that because 6 equals 6, but 6 does not equal 12? Can you cover up a number? No. That's just the same thing again. Whoops. I'm just wondering, is there another symbol we could put in here that would make this work? 6 equals 6 plus 12, sure. Probably not great that I've got all these extra things here. Okay, where can we begin? Ooh, 31 and 13. So they're flipped. Can we flip numbers? Is there something we can put here that will flip them over? Oh, this looks like a mirror image, so it could be that. But maybe you need 2 things. Maybe you need like that, but then also, is there one that's like flipped, like top to, oh, there's a win one as well. I didn't even notice. Okay. Are there any that are like flipped vertically? Maybe that combined with something else will do something. That's assuming that like they can go, like how else do these numbers connect to anything? I'm probably being misled by this. It's not just like plus and equals, and they don't just have to be in a line in some way. Wait, what were we saying this is? This is plus. But then how do I connect that to a number? What the heck? What the heck? Are these somehow numbers? That didn't make that go down, which is interesting. What would make it go down? Maybe nothing. But then how do you interact with anything then? Okay, I've just got to experiment. Ooh, Wait, what? Okay. This is why experimenting is important. So that raises that 6 up, but in this direction, it just like creates a 6. In this direction, it creates a 6 outside the board. What happens if I do that to another number? Okay, let's make this 6 show up again using U. I need to not just leave stuff on the board. It's making a huge mess. So we can create new numbers. If we do it here, just the 1, just the 1. Why just the 1, whereas here we get 2? Maybe because you're there? Which we thought was plus... Okay, so that does some kind of like duplicating. It doesn't duplicate those though, only numbers. But only raised numbers, I guess. Let's write something down for that. That's a crown. Copies or something. I mean, can we do something with that? 6 and 14, but they're like right next to each other. Let's try other things. Let's keep you there just so we've got 2 numbers up. But you, okay, 19. Where the heck does that come from? So it's always 19, 1991. Curious. I mean, it could be possible that that is just flipping. Are we saying that's flip? But these are not next to each other. That's the problem there. Like maybe that is flip. I mean, I could see how that symbol might mean that. As in, it doesn't actually flip it, but it like just reverses the number, basically. And if that is true, I mean, that works for this. It's not add. It's just reverse the number. 6 reverse is 6. And then maybe the other thing was double. Ooh, interesting. Maybe you were actually double. And so this isn't actually an equation. It's just a relation between the 2 numbers that are on each side of the thing. Okay. Okay. So yeah, we can see that reversing that here as well. Let's like reverse it again. We'll get 19 again, right? Yep. And reverse it again. We get 91. Yep. Cool. All right. So wait, what else have we got going on? So why do I get 19 from that? 19. Then 58. Then max. I guess it only goes up to 99. 6 to 19. It is 19 in every direction. And if we do it here, this is also, oh, not that one, this one. It's also 19. 19. 6 to 19. I mean, we could triple it and add 1. Triple 19. What would that be? 38. Oh. 48, 57. Oh, that does work out. Triple and add 1? That's just so random. That's so random. Okay, let's try some more experiments. So we think that might be reverse. We were tricked. Reverse. The other one might be double, maybe. And then this like circular one means maybe triple plus 1. That feels a bit like too random. I bet it's something else, but whatever. So we could also test if we do this and then reverse, we get 85. Yep, of course we do. And then 13 from that. So that made 6 before. We were thinking copy. That makes 13. Could it be the 13s go into 85? 13, 26, 39, 78, that would be no, they do not. Ooh, also makes 13 from that. That's interesting. So regardless of which way around those numbers are, you get 13. Oh, add the digits. Add the digits, of course. 1 and 9 makes 10. Yeah, okay. So crown is add digits. Add digits. This is cute. Oh gosh, we gotta satisfy all these. Let's do that though, and then also, so 13, and then also do this. So if it is times 3 plus 1, I mean that also makes sense for the picture, doesn't it? 3 around the outside and then 1 in the middle. But if it is, then it's 40. Yeah, okay, cool. And then it's just a u we've got left to figure out. Add 1. Ooh, minus 1. Maybe depending on whether it's odd or even or something. So odd minus 1, odd minus 1, even add 1, odd minus 1, even add 1. Seems to be working. Okay. Oh, so if you chain them together. Okay, so 36 chained across all of these. Maybe that's not the best one to start with. Okay, so we effectively... Okay, let's try and make something happen. Is there like an easy way to get rid of these things? No. Okay. But sure, we might as well do that. And we might as well do this, right? Not that, this. Because those need to be raised, and so why not raise them in the simplest possible way? So then we need to get a 1 here. Well, 1 here, sorry. Because this needs to be next to a 1. Well, this needs between a 1 and a 1. Now, what have we got? Wait, what was this one again? Oh, add 1 if even. Is there a nice way to say that? Add 1 if even. I don't know. I was going to write it down anyway. Plus 1 even, minus 1 odd. Okay. So how do we get to 1 from maybe from 6? Add digits, you still get 6. Oh, do we actually think that's double? No, we do not. So that does make it 12. Makes it 14. Let's just chain a bunch of these together, see what we get. 6 to 12, that's fine. 12, 14. That's adding 2. That's adding 4. This is going to add 6 for some reason. No, 8. 2, 4, 6. 2, 4, 8. So is the next one going to add? Not that I can do it there, but I could do it a different direction. So that was, I think, 8, so 16. Which would make 42. 32. Add 6. It's adding the last digit. 2, 4, 8, 6. Adding 2 to that. So just add the last digit on. Add 4 to 34, you get 38. Add 8 to 38, you get 46. Okay, cool. All right. So it's not double, it's add the last digit. Add last digit. Okay, but how do I get from 6 to 1? So we can reverse numbers, we can times by 3 plus 1. We can plus 1, and then minus 1. We can add the digits, we can add last digit. So we can make 12. Ooh, we can make 12. Then somehow get just the 1 out of it. That's not going to happen. Can you place on those? You can. So we could chain together like 4 things. Oh my gosh, what? Okay, what about how do we get smaller numbers out of this basically? Because they all go up. Yeah, they all increase. By getting a 0. Ooh. Okay. So we get 10. If we get like 10 here. Interesting. Whoa. Are these all reversible then? Because I feel like you need to be able to read these all backwards. I guess they are all reversible. No, add last digit is not. So that's kind of interesting. Whatever. Whatever. So 10 and then reverse 10 somehow. But I can't get from there to there. I feel like I need a better plan. I can get 7. I can't add 3. I could times 3, add 1. I can then, yes. I can make this 10 by adding the digits together. So the crown goes here. Ta-da! Neat. Cool. Next. We might as well put that back in. Next, we have a 10 here. There's a 14 here. Can we just connect these up somehow? Can we just connect these up somehow? 10 and 14. Just looking at my whiteboard. Add last digit will do nothing. Reverse will make 1. Times 3 plus 1. That's not going to be good. 99 over here as well. We don't necessarily come from here though. That's the thing. We can plus 1. 11. We can add digits. Get 1. Yeah, I don't think we're going from there. Unless there's like, I feel like this is the only real way to do this. Except I guess these could all be chained together instead of, like, yeah, we could do that instead. Like you can basically put them anywhere in the sequence as long as, yeah, whatever, as long as the number gets generated. Maybe we could go that way to there. Or maybe there's something else we can do. Maybe we can just go 6 to 14. We don't have a double. We do have an add digits. It'll be 6 still. We have a reverse. We have a times 3 plus 1. I feel like this is going to be very valuable. 19 to get to 14. I'm not going to be able to get there with one of these. I can get to 10 again. That's not good. 19, we could do 19 here and then maybe go this way somehow. Flip you. 85. Do we have an 85 anywhere? No, we don't. We have a 92. I think I can get to a 92 from here. Well, this is useful, but then maybe it's like that after a plus. Well, it'll be a minus actually. This one. 55. So also have this 12 up here as well. So something that's good. Okay, should we reverse engineer this? So it's going to be 63 there. So we want 36 at the end. 63. It's going to be add 1 if even, so 62. This is add last digit. Oh gosh. So maybe 61, add 1. This is flip again, so 16. And this is times 3 plus 1, 5. Okay, that works out quite nicely. So if we can get a 5 here, we're done. But we have to do these as well at the same time. This is scary. This is very scary, actually. Maybe we do something up here. Ooh, yes, we do something up here first. Okay, flip U. 91, cool. I guess these can be part of more than one thing as well. If we get a 22 there, that would also satisfy that. Add 3 somehow. Add 3 somehow. add digits, but I mean, it could come from this 12 instead. Holy moly, this is complicated. What have I got myself in for? So we think this is going to be a 5. That's fine. That's totally fine. 14, I can't get to. I can get to 31 times 3 plus 1. That's close to 99, but not 99. 37 minus 5. Let's see how I would do that. 3. 10 for that would be nice if I could get this to a 10. 10 and then times 3 plus 1. I don't think I can get that to a 10 though, using any of the operators I've got. Digits, no. Reverse, 21. That's kind of interesting. 21. I still don't see how we get to there though, do I? Just like constantly looking back and forth between this and my whiteboard. So just a reminder, this is reverse. This is add the last digit. This is times 3 plus 1. This is plus 1 if even, minus 1 if odd. And this one is add digits. So we make 3. Does not feel particularly useful. 12 to 24, if we had like a double, would be fine, but we don't have a double. But also, like, getting like around this corner is kind of tricky because we can't just make a number here. So yeah, like it's almost like we have to go from 91 to 24 maybe. I'm going to assume this has many solutions. Let's do what, like if you make max and then you like flip it, what happens? Yeah, exam. Oh my gosh, is there actually a way to make the words win? Error. 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 Okay, maybe not. Maybe that's just a funny joke. No, there is totally going to be a way to make the words win, isn't there, somehow? Maybe. So you could add up the digits, get 10 times by... That's not helping. That's not helping at all. We could add the last digit to get 92, which is actually kind of interesting, which is this one. It's not interesting for getting to 4, although it's not terrible. I mean, it kind of is. There's not one operation I can do between 92 and 4. So I think whatever's here is going to be going from the 6 to the 4, but also from the 91 to the 24. Wait, how is this ever going to be satisfied? Okay, that's something I don't understand yet. Oh, I guess they're not going to be satisfied by this, but they're going to be satisfied by something else. And this is just red herring? Just red herring, really? Because yes, this add last digit doesn't work either way round, whereas and this for adding all the digits. Oh, I guess we could figure these out since there's literally only one space between them. 10 and 70. But which way does it go? Is it just if it works either way, it's fine? But also, how can this work? Add digits. 9 and 5, 14. Plus 1. I mean, I can just like try them all. But I feel like this is not going to work. I think I'm missing another rule here. I'm definitely missing another rule. I can't put things on top of these. I am definitely missing another rule because this cannot work. Huh. Okay, this has to get satisfied at some point. Can't put stuff on top of the walls. I was thinking, like, could you do a diagonal thing? All right, okay, let's try all of them in every position. In both positions. But like, I'm pretty certain at a glance that none of these works. Oh, you have to remove it. How the heck are you going to get solved? There is a rule I do not know somehow. Oh, we go around the outside, don't we? We've learned that that's a thing. Oh, no. I wonder if this counts. Like, if I put a number here, let's see if we can do that. Do that. Do this. No, okay. That is just blank. Okay, I think we do have to go around the outside, though. That's spooky. Can we do 31 and 95 times 3? Yeah, that's easy. It's this one and then that one. Is it not? Times 3 plus 1, 94. Plus 1. Times 3 plus 1, 94. Plus 1. Wait, why? Oh, you have to be lit up first. Okay, I think that will be right once I get there. 37 minus 6 somehow. Don't have a way of doing that. We can like add you up to make 3. That's not adding you up. Yes, it is. We can add on that to get 14. That made everything unhappy, of course. Oh, that's interesting. I guess that doesn't go down if you're satisfied, though, I think. Maybe. Maybe I'm not understanding something there still. 14, 41. I get 41. What happens if I flip 21? Add digits. Add -1 times by 3. Add last digit. 22. Flip 12 again. I can't see a way of getting to 31 from here. Yes, I can. Add 1, then flip. Okay. Cool, and then that's lit up. That is unhappy, though, which is a concern. Unless, yes, it's fine to like satisfy that separately. But now I'm worried. Now I'm very... But then how could that ever be? That can never be true. Yeah, that just can never be true. So I'm just going to have to assume that it's possible to satisfy you separately from this. But then why does it exist? There's got to be some reason. Add digits. Why is it not just a wall? Okay, well that's that. 95. And yeah, no. Well, I guess one of them had to be raised. So hold on, let's think about them again. So adding the digits, no. 14. Add 1, -1, no. Times 3, no. Add last digit, get 100. Reverse, get 59. No, there's nothing I could put there that would connect to you. Can you actually place things outside? No. So actually, no, even if I send a thing outside, I don't know how I'd get it around the corner. There's got to be something I can do with this somehow. It doesn't send stuff that way. So sure, I can get them outside, but I can't redirect them around in any way. I can get a number there, but it doesn't affect this thing. Curious. Very, very curious. And there's definitely nothing that would go from 10 to 70. Or maybe there's something that would go from 70 to 10. Add digits, no. +1, no. Times 3 plus 1, no. Add last digit, no. Reverse, that would make 7. 10 to 70. No. Oh. Okay, there's something weird going on with this bit for sure, but I don't think we're going to figure that out right now. Let's maybe work on something else instead. We've got 6 out of 18. That's all right progress. Maybe we'll stop there for now, actually, and we'll continue next time. This is certainly a bit of a conundrum, isn't it? All right, I'll see you then for some more completely normal maths. All right, goodbye.